What if, in the grand orchestra of the cosmos, there was a galaxy that made no sound, a vast cathedral of stars, utterly silent where there should be life, storms, and cosmic fury? Space is not silent. Astronomers call it a vacuum, but the cosmos hums with energy, light waves rippling across intergalactic distances, radio emissions whispering from pulsars, the soft hiss of the cosmic microwave background, the afterglow of the Big Bang itself. Even in its vast emptiness, the universe is alive with motion and change. But somewhere, against this eternal score, lies a galaxy where the music stops. Its light reaches us after millions of years of travel, its faint glow barely brushing the edges of our telescopes. At first glance, it looks ordinary, a dim smudge lost among billions of others. Yet closer study reveals something almost unsettling. This galaxy does not behave like the rest. It shines, but not brightly enough. It drifts through cosmic time without the telltale signatures of birth or death among its stars. No massive nurseries of gas collapse into blazing suns. No ancient giants explode into supernova for planets and life. Its stars exist in a kind of arrested development, neither young nor violently dying, as though the entire system holds its breath. Astronomers give it names, catalog numbers, coordinates, yet behind those labels grows a sense of quiet dissonance. Galaxies are supposed to be messy, dynamic things. They collide, merge, ignite with star formation, or fall silent only after long, predictable ages. But this one seems to have skipped steps in the cosmic playbook. It should not be this still, and in the language of science, should not is where curiosity begins. Perhaps some suggested it was once a normal spiral galaxy, like our own Milky Way, its arms filled with gas and newborn stars. Maybe a collision long ago stripped it bare, tearing away the material needed to form new suns. But collisions leave scars, tidal tails of stars, streams of gas stretching like cosmic fingerprints. This galaxy bears none. It floats alone, pristine, untouched. Others wondered if it might be unimaginably old. A fossil from the universe's youth burning through its fuel in a reckless burst, eons ago now left to fade. But even galaxies with long-dead hearts carry the signatures of their past dense cores. Black holes still feasting on infalling matter. Here there is nothing. It is as though it was born into silence. And in astronomy, silence is rarely simple. Across decades, telescopes turn toward it like question marks aimed at the sky. The Hubble Space Telescope glimpses its structure. Radio observatories listen for neutral hydrogen gas, the raw fuel for future stars, and find almost none. Spectrographs measure its light, searching for clues in the color of its stars. What they find unsettles expectations. The stars are not young, yet not ancient enough to explain the galaxy's quiet nature. Their light suggests ages of several billion years, middle-aged in cosmic terms. By all rights, such a galaxy should still be forming new generations of suns. Yet it doves in single, quotes the silence persists. Galaxies like Messier 87 in Virgo blaze with activity, their central black holes hurling jets of matter across space. Starburst galaxies like M82 form stars at a furious rate, entire clusters igniting in cosmic fireworks. Even elliptical galaxies, often called red and dead, carry traces of past collisions and dormant violence. But this galaxy seems empty, not of stars, but of story, and that absence becomes its own mystery. For scientists, the universe is a puzzle slowly assembled across centuries. Each discovery adds a piece, bringing the picture into sharper focus. But sometimes, a single object appears that refuses to fit a reminder that the cosmos does not owe us simplicity. This galaxy becomes one such reminder. Could dark matter, the invisible mass-shaping galaxies, play a role? Perhaps it formed differently here, altering the galaxy's fate. Could it be hiding a faint trickle of star formation, too subtle for current instruments to detect? Or does it hint at physics, not yet imagined? Processes beyond today's models of cosmic evolution. Each possibility opens a door, and behind each door waits a deeper question. And so, scientists return again and again, instruments improving with each decade. The James Webb Space Telescope, with its infrared eyes, peers farther into dust and time, hoping to uncover what earlier generations could not. Maybe the silence is only apparent. Maybe, buried beneath its stillness, the galaxy carries secrets about the first moments after the Big Bang, or the slow death of cosmic structures yet to come. But as the data grows, so does the strangeness. Because if this galaxy is not unique, if others like it drift unseen across the cosmos, then our picture of how galaxies live and die may be incomplete. Perhaps cosmic history allows for long silences, entire systems suspended between birth and decay. Like notes held too long in a song we thought we understood. And if the universe can fall silent here, where else might it? Light from this galaxy began its journey before Earth had continents shaped as they are now, before life crawled from oceans, before the sky held anything but instinctive wonder for human eyes. For millions of years, that light crossed the dark. Carrying a story whose meaning we are only beginning to suspect, it reaches us now. Faint but insistent, a whisper from a place where the stars refuse to sing, and so the mystery deepens, a galaxy that breaks the rules without telling us why. In the next chapter, we turn to the astronomers who first found this ghost in the sky, and the moment they realized the universe was hiding something extraordinary. It began, as so many cosmic mysteries do, with a flicker of light on a photographic plate in the middle decades of the 20th century. When astronomy still carried the romance of long, cold nights and ink-stained notebooks, a faint smear of brightness appeared in the eyepieces of telescopes in the northern hemisphere. It was nothing spectacular, no brilliant quasar or colliding galaxy lighting up headlines, just a dim elliptical glow catalogued among thousands of others. But there was something odd about it. In an age before space telescopes, astronomers relied on light alone, its brightness, its spectrum, its subtle shifts in color to decipher the lives of galaxies. From these clues, they could measure distances, ages, the birth of stars, the death of giants. Yet this object yielded none of the usual answers. Its light was steady, almost eerily so. The spectral lines that revealed chemical fingerprints carried no signs of the hot young stars common in most galaxies. Nor were there the brilliant, short-lived blue giants, whose deaths explode into supernova and seed the cosmos with heavy elements. The galaxy glowed like an ember long after the fire had gone out. At first, the observers thought it was simply one of those red and dead elliptical galaxies, common in the universe, where star formation had ended billions of years ago. But something didn't fit. Even dead galaxies bore traces of a turbulent youth. Central black holes accrete matter, shells of stars from past collisions, faint glimmers of new star birth clinging to their outskirts. This one showed nothing. It was quiet. Too quiet. In the 1960s, radio astronomy added new tools to the search. The great dishes at Arecibo, Jodrell Bank, and Green Bank were sweeping the skies, detecting the invisible hydrogen gas from which new stars ignite. Where optical telescopes saw only starlight, radio antennas could trace the raw material of creation itself, pointed toward this silent galaxy. The radio telescopes found almost nothing. No dense clouds of hydrogen, no signs of recent birth. A galaxy adrift in the dark, with no fuel left to burn. Yet its stars were not ancient enough for such silence. This was the first mini-reveal, the puzzle deepening. If the galaxy was too young to be so still, something else had stripped or suppressed its ability to form stars. But what some astronomers suspected environment, galaxies in crowded clusters can be stripped of gas by their neighbors, left barren as they fall through hot plasma that scours them clean. Perhaps this galaxy had once plunged through such a place, but its location told another story. It floated in cosmic solitude, far from bustling clusters or violent mergers. No neighboring giants loomed nearby to steal its birthright of gas and dust. It was alone, a ghost adrift in intergalactic darkness. By the 1970s, better spectrographs measured its stars more precisely. Their ages spanned billions of years, but not enough to explain the total absence of youth. Even galaxies winding toward death usually carry at least a few bright young stars clinging to life. This one seemed frozen, as if time itself had slowed. Within its borders, the astronomers argued in conferences and journals. One camp insisted it was a simple outlier, a statistical oddity in the vast menagerie of galaxies. After all, the universe contains trillions of them. Some are bound to break the rules without rewriting them, but others wondered if something deeper lurked. Here, a process not yet understood, a missing chapter in the story of cosmic evolution, mini-reveal followed mini-reveal. Photographic plates gave way to digital detectors. New observatories scanned the galaxy in ultraviolet, infrared, X-rays. Still, no sign of the usual engines of galactic life appeared. No central black hole blazing in X-ray fury. No ultraviolet flare of newborn stars. Only the same steady, silent glow. By the 1980s, some astronomers began whispering stranger ideas. Could it be primordial? A relic from the earliest epochs, formed under conditions unlike anything in the modern universe. If so, studying it might reveal secrets about the first galaxies to condense after the Big Bang. Others speculated about dark matter. This invisible substance, outweighing normal matter 5-to-1, binds galaxies together with its gravity. What if this galaxy had an unusual distribution of dark matter, shaping its fate in ways unseen? The debates grew sharper because astronomy was entering its precision age. Computers modeled galaxy formation in vast simulations. Supercomputers traced billions of years of cosmic history, watching virtual galaxies collide, merge, ignite, and fade. None of them produced a galaxy. Like this, it was as if nature had written a single exception to its cosmic laws and left it drifting. In the dark, for astronomers to find, in 1990, the launch of the Hubble Space Telescope brought unprecedented clarity, turning its golden eye toward the silent galaxy. Hubble resolved individual stars in its outskirts, probing deeper than ground-based telescopes ever could. The result? More strangeness. The stars showed a surprising uniformity, as though born in one ancient epoch and then abandoned. No later generations had followed. Galaxies are supposed to evolve, like living things: youth, chaos, maturity, decay. This one seemed born old, as if it had skipped childhood entirely. By century's end, astronomers had given it a nickname spoken half-jokingly at conferences: the Ghost Galaxy. Not because it was faint, though it was. Not because it was dead, though in some sense it was that too. But because it felt like an apparition from another cosmic order, a thing glimpsed out of the corner of science's eye. Impossible, yet undeniable. And as telescopes improved, the mystery only grew, because the deeper they looked, the more the galaxy seemed to resist explanation, as though holding some secret about how the cosmos builds its islands of stars. And so the stage was set, a lonely galaxy adrift in silence, defying every model of birth and death. In the next chapter, the mystery deepens as scientists turn from discovery to confrontation, forcing physics itself to answer questions it does not yet understand. Science advances by patterns. Galaxies are born in gas-rich halos, ignite with starbursts, grow through collisions, and settle into spirals or ellipticals shaped by time and gravity. Astronomers can trace these life cycles with exquisite detail, mapping when stars form, when black holes awaken, when elements heavier than helium spread into the cosmic sea. But here was a galaxy that followed none of these rules. By the late 20th century, technology had sharpened. Spectroscopy revealed the chemical fingerprints of its stars. Radio telescopes hunted for hydrogen gas, the fuel of star formation. Infrared observatories probed for faint warmth from dust grains, where new suns usually gestate. Every instrument returned the same verdict: silence. No sprawling molecular clouds, no newborn blue stars burning hot and fast, no ultraviolet glare from massive stellar nurseries. This galaxy had light, but no life, at least not in the stellar sense. And yet, its stars were not as ancient as a dead galaxy's ought to be. This was the first contradiction. Normally, when galaxies exhaust their fuel, it happens slowly. Residual gas clings to their outskirts. Late star formation flickers along for billions of years. But here, the process seemed to have ended abruptly, like a clock stopping mid-tick. No one knew what had slammed the brakes. Computer simulations tried to reconstruct its history, feeding in masses, ages, metallicities, and motions. Astronomers ran galaxy formation models forward and backward in time. They simulated mergers, stellar winds, gravitational harassment from neighbors, even hypothetical collisions with invisible gas clouds. Nothing fit, in every model. Galaxies like this either collapsed into quiescence after long predictable epochs, or reignited when fresh gas flowed in from the cosmic web. This one had done neither. And then came the second contradiction, when astronomers mapped the motions of its stars. They found evidence for a heavy halo of dark matter, the invisible scaffolding that holds galaxies together. Normally, dark matter halos pull in gas from intergalactic space, replenishing galaxies over cosmic time. But here, despite a massive halo, no new material seemed to arrive. It was like finding a fertile valley with rich soil, yet no rain falls, no seed sprout, no life returns. Some proposed it lay in a cosmic desert, far from the filaments of gas threading the universe together. Galaxies feed along these filaments like beads on a string. Cut off from them, they starve. But mapping its surroundings revealed another surprise. It wasn't completely alone. Faint dwarf galaxies drifted in the region, some still forming stars. At modest rates, why did they survive while this larger system froze in silence? The universe was breaking its own rules. By the early 2000s, space telescopes added sharper eyes. The Chandra X-ray Observatory searched its center for the telltale glow of a supermassive black hole feeding on gas. Most galaxies, even quiet ones, hide such monsters at their cores. But here, no X-rays flared. If a black hole existed, in perfect darkness. Meanwhile, Europe's Herschel Space Observatory hunted for coal dust, the ashes of dead stars, and the cradles of new ones. Again, almost nothing. A few grains scattered like relics of a forgotten age, but no dense clouds waiting to collapse into suns. Then came the twist. Using Hubble and ground-based telescopes together, astronomers measured its stars with unprecedented precision. Their chemical compositions revealed surprisingly low metallicity, fewer heavy elements than expected for its brightness and mass. That hinted at something astonishing. This galaxy might be far older than suspected. Perhaps its stars formed early, before many generations of supernova enriched the cosmos with metals. If true, it could be a living fossil from an epoch when the universe itself was young. But even fossils carry scars of time. This one looked untouched, as though cosmic history had passed it by. Conflicting theories sprouted like wildflowers. One camp argued for a primordial relic, a galaxy born in the first billion years after the Big Bang, now drifting unchanged through deep time. Another proposed an exotic dark matter scenario. Maybe its halo formed differently, hoarding mass but somehow blocking gas inflows. A more radical idea emerged from cosmological simulations. What if this galaxy lived in a pocket of space with slightly different conditions, a rare fluctuation in density, temperature, or even dark energy that froze its evolution? Each hypothesis carried implications beyond this one system. If primordial relic, then the early universe built galaxies more diversely than thought. If dark matter anomaly, then our understanding of cosmic structure needed revision. If rare fluctuation, then the smoothness of cosmic laws might hide tiny local exceptions, cracks in what we thought was universal symmetry, and beneath every explanation lurked a deeper unease. What if galaxies like this weren't rare at all? What if thousands drifted in darkness, missed because they shine too faintly, or because astronomers rarely look in the empty stretches between clusters? Already, surveys like the Sloan Digital Sky Survey were cataloging oddball galaxies, ultra-diffuse giants, starless dark matter clumps, faint smudges on the edge of detectability. The silent galaxy might be the first hint of a hidden population rewriting cosmic history. By the 2010s, the mystery reached a fever pitch. The James Webb Space Telescope promised infrared eyes sharp enough to peer through cosmic dust, to weigh ancient stars with precision unmatched in human history. If this galaxy was as old or as strange as the data hinted, Webb might finally reveal its past. Or it might make the mystery worse, because in science, every answer carries another question nested inside it, like a Russian doll carved from night. And this galaxy, this silent wanderer in the dark, seemed determined to ask the one question cosmology feared most. What if our picture of the universe is incomplete? And so the mystery tightens its grip. A galaxy without a past, without a future, drifting through equations that cannot hold it. In the final chapter, we step back from the data into philosophy, wonder, and fear, to ask what its silence might mean for the fate of everything we know. Across decades of study, through the rise of supercomputers and space telescopes, the silent galaxy has yielded no clear truth. Data has sharpened. Models have grown intricate. Observations have reached wavelengths across the spectrum, from radio to X-rays, yet the mystery remains intact, like a stone in the current of progress. Refusing to erode, this galaxy sits there, luminous but lifeless, as though time itself chose to pass it by. And so, when science cannot explain, imagination begins to circle the unanswered edges. Some cosmologists wonder if it carries echoes from the universe's earliest epoch, a fossil from a time before galaxies learned the familiar rhythms of birth and death. Perhaps it formed in the primordial chaos just after the Big Bang, when hydrogen clouds collapsed into the first stars. Maybe it burned through its fuel in one furious burst and then fell silent, drifting through cosmic time as a relic of creation's first experiments. Others suggest stranger possibilities. What if this galaxy lies in a region of space where the cosmic laws themselves bend? Modern physics rests on the assumption that the universe is uniform, that gravity, electromagnetism, the nuclear forces work the same everywhere. But what if, in some rare corners of reality, those rules shimmer and shift like heat haze above? A galaxy where physics runs differently, would not just challenge cosmology, it would challenge the very assumption of a single, consistent universe. And then there are the whispers at the edge of theory, ideas too bold for textbooks, too haunting to ignore. Some physicists studying dark energy, the mysterious force, accelerating cosmic expansion, wonder if galaxies like this hint at universes before ours. If reality passes through cycles of birth and death, each cosmic generation leaving faint fingerprints on the next, perhaps this silent system is a survivor from something older than the Big Bang itself. Others, staring at the cold equations of entropy, read the galaxy as a warning. Entropy, the tendency toward disorder, is the deep current pulling everything toward silence. Stars burn out, matter decays, energy spreads thin. In the far future, trillions of years from now, galaxies across the cosmos will fade one by one until only black holes remain, then evaporate into darkness. Perhaps this galaxy lives ahead of its time, a preview of that distant, inevitable, quiet. The idea chills even seasoned astronomers, that the universe may carry pockets of its own ending scattered through space, like fallen leaves ahead of winter. And yet, the silence is not purely grim. Some find beauty in it, the way a pause in music carries its own meaning, the way a breath held too long sharpens attention. In a cosmos so full of violence, supernova tearing stars apart, quasars blazing like cosmic furnaces, galaxies colliding in titanic mergers, here drifts a place of stillness, almost of peace. Its stars glow with the steady light of persistence. No chaos, no collapse. Just endurance across unimaginable time. Perhaps, some suggest, the galaxy even carries a kind of message, not in words or radio signals, but in existence itself, a reminder that the universe is not obliged to be simple, that life and meaning emerge not from certainty, but from mystery, because humanity, for all its equations and instruments, still stands at the shoreline of an ocean too vast to measure. Each discovery lights only a small circle in the dark, and beyond that glow, the unknown stretches, silent and infinite. This galaxy drifts just beyond that circle, luminous yet hidden, a question made of stars. And maybe that is why it unsettles. US.Science thrives on answers, on patterns drawn from chaos. But the universe holds no promise that its patterns will always be clear or complete. Perhaps some truths will always recede as we approach, like a horizon never reached. The silent galaxy reminds us that reality is under no obligation to make sense. Not yet. It waits at the edge of comprehension, neither explaining nor denying, like a riddle spoken in a language we have only begun to learn. And when astronomers pack their instruments after another night of data, when supercomputers finish another round of simulations ending in contradiction, the galaxy remains there, drifting through intergalactic dark, offering nothing but its quiet persistence. It asks no questions, it gives no answers, it simply exists, luminous, still unyielding, and so the mystery lingers. carrying the faint suggestion that our universe is vaster, stranger, and more layered than the human mind can yet hold. Perhaps in some future age, with tools not yet imagined and theories not yet born, the silence will break and its meaning will pour forth like light from a long-closed door. Or perhaps some secrets are meant to remain, not to frustrate us, but to remind us of wonder itself, for without mystery, the stars would be only points of light. It is the darkness around them that makes us dream. And so the galaxy drifts on. A question without an answer, a note held too long in the music of the cosmos. Somewhere, beyond what we can know, perhaps the universe is still composing.